Um, I'm Saheed Lasisi, and I work for JPMorgan Payments. And this session is session for the API Days London 2023. And what we're talking about today basically is the exploration of AIs in API architecture. And the topic of discussion actually is, can AI replace the API architect? So, um, just to give us a little bit of agenda today, we would have the introduction. We will take you through AI and API architecture, limitations of AI within this space. We'll take you through a case study. We'll look at future predictions and trends, and then we'll ask the question again if AI can replace the API architect. So basically, APIs and AIs are the forefront of business and technological transformation. AIs have been coined since 1956 from the Diamond Conference. And all of a sudden, last year, there was a buzz in AI itself through the advent of generative AI. And since then, there's been some new innovations across the board when it comes to IT generally, but in particular with APIs. APIs have been able to um, somehow kind of like impact AIs and vice versa. And that is what we're going to look at in the next slide. So we'll talk about the evolution of AI since 1956. As I said, the term AI was coined in 1956 itself to actually demonstrate the mimicking or the synthesizing of human intelligence. But ever since, there has been so many innovations around the world of AI, mostly in research and in academia. But last year, something definitive happened, which is an human chatbot that was actually programmed and released by OpenAI. And since then, there has been tremendous, what would I say, interest in Chat GPT, in GPT generally. But what is generative AI? So basically, generative AI is a technology that basically leverages artificial intelligence models to produce new data based on certain data that has been trained upon. But not only that, it also kind of like uses a term, or let me say, a neural network called a discriminator to actually validate the production that it has actually produced, which means new data that is generated from trained data is actually being validated by an agent called a discriminator within that itself. So that takes us to the next slide. And basically, to a layman, what is generative AI? Generative AI basically is a digital artist. It recognizes patterns within this trained data or within this particular vast information that you've given to it. It paints new scenes after seeing many landscapes, seeing many things, experience, for example. And what it does basically that is unique is that rather than producing exactly the same content that it has seen, it could basically produce new content based on what it has actually seen previously. Two things. Two things. It has learned. It has learned the. It has learned the. It has learned how to actually um, create these landscapes by actually seeing those landscapes, by painting them, by not necessarily. So basically, it is not necessarily playing back those landscapes, and that is what you see with generative AI. When it comes to API architecture, this is an experience that improves the craft of an API architect because we see, we design on a daily basis, we advocate, we do reviews, we perform end-to-end solution architecture. These things are not the same. And as such, AI comes at a pivotal time, especially generative AI, in the sense that there is some part of this work that could actually be delegated to an AI and governed by the architect. But let's talk about who is an API architect. So an API architect is someone that designs APIs, someone that advocates for his API designs or his API architecture, someone that reviews APIs, someone that actually performs end-to-end solution architecture within the space of an API solution, somebody that manages stakeholders, someone that actually does requirements elicitation, requirements gathering, and all that. Someone that actually identifies trends, contributes to open source software, performs some level of data modeling or understands data, performs some tooling strategy, someone that actually does security risk assessments, performs security design, someone that actually understands the API lifecycle end to end and architects that lifecycle, someone that understands the API landscape, someone that understands the API strategy and can craft a strategy, someone that can actually execute also the API strategy by having a roadmap and having some roadmap deliverables, and someone that actually kind of like knows API governance and can actually lay out what those governance rules are. Somebody that can actually go in there and perform some proof of concepts and so on and so forth. So the role of API, what I do of AI in API architecture is actually varied from entry level architects to distinguished architects or expert level architects. And it's empowering everybody entirely. The idea is that with generative AI, we can actually augment human creativity, not necessarily kind of replace humans. So, from all the things that I've actually mentioned earlier, the fact is the field of architecture is based on patterns, blueprints, designs, experience to some extent, and references. And as such, this gives us an opportunity in terms of AI to actually be able to provide some amplified way of actually crafting APIs without mistakes, limiting human intervention to the least, and also bringing in some level of intelligence to something that is supposed to be monotonous. But also, what it means is that in API architecture, we could actually evolve the way it is done today to make it a bit more dynamic in real time. So, um, AI is empowering API architecture in different ways. One way that AI has already started empowering architecture is in terms of requirements. So when we talk about requirements, in terms of requirements gathering, in terms of collation of requirements from different data sources, be it emails, chats, reference documents, and so on and so forth. And then in terms of templating, you would have seen a lot of AI tools that are actually into the space of SDKs production and all that. But sometimes you need a good template for a great API. So AIs are there to actually produce template based on business domains, solution domains, or based on what we call cross-cutting concerns, for example. And depending on what your target is, you can actually create this different API templates. And in real time, also, it means that even though you have these templates, it means as reference blueprints for your APIs, it means AI could also add value by maintaining those templates or also by actually instantiating those templates by creating an API for you out of those templates based on your requirements. And that translates straight into API design that it doesn't need to be done from scratch since there is a specification already in terms of the Open API standards. And also you've got templates, you've got different best practices, you've got different security schemes that you could actually embed right from the start. And to some extent also, if you have done some work in terms of data modeling and you have requirements, you could all bring that together into, let me say, an amplified API design, leveraging AI. And that's the same with architecture design as well. We have reference architectures, we have reference blueprints. You can actually let AI maintain those reference blueprints by actually having a base that is based on this particular standard, that is based on some programmatic concepts, or using things like diagram as code and all that, and you can actually evolve your architecture without having to actually maintain it manually. So, which means you can introduce new features into your architecture, change things dynamically without having to do so, but just by instructing AI on doing that. Validations, governance, LinkedIn, these are things that AI are good at. Patterns, of course, using patterns, or for example, creating new patterns or crafting new patterns. These are some other areas where AI can actually help as well. And documentation is another way. I'm reading code, documenting the code, or for example, reading a vast amount of data, looking at different areas of opportunities and using AI to actually converge all that. Congruency, for example, is also another key area where AI can actually help in terms of documentation in a vast API landscape. Code generation, that has been done already in terms of legacy systems where you have legacy APIs or legacy backend systems that you want to create an API out of. You could actually leverage AI in understanding what the code does and use that as a reverse engineering tool, and then perform different kind of let me say activities in actually bringing out the intellectual property or expertise that you have encoded into those legacy systems, a layer above where it was currently. In terms of testing, um, AI provides a great, let me say, a vast array of capabilities when it comes to testing, and I think this is where AI could actually beat a human tester, because it could actually test um, as much paths, as much permutations or combinations, simply because it's not having to do it manually and it's not having to think of use cases, because it could test beforehand and test after and it could look at the code and actually come up with tests, scan and see where vulnerabilities are using best practices, using the constructs of the language itself, that's or the standard that that particular let me say artifact that you're testing actually supports. And data modeling and security are strong areas where AI is actually let me say very powerful, simply because out of the box these based on references. These are based on standards. These are not fluid, and they're not open to conversations or arguments, for example, in reality. And autonomous integrations, autonomous orchestrations, that's where we see AI going in the future, simply because we today we perform integration based on information that we have, and instructing different software systems in actually providing services or capabilities that we actually hope to get. Whereas in the future, um, we would actually be getting services out of the box without having been told, without actually asking for it, but probably being proposed to us, simply because with autonomous integrations and autonomous orchestrations, the AI is left to find opportunities of orchestrating or integrating without actually being told. And this basically leaves the intelligence to the AI to actually perform integrations without having to tell it what to do. And it also means is that we don't continuously build in software for feature's sake. We rather build software for intelligent solutions. In terms of blueprints, AI is also coming to strong, what call it, strong use here, in the sense that blueprints are easy to actually adopt, to instantiate, to create based on certain standards, based on certain artifacts that we have already, and we can craft out a blueprint of that. And people who want to consume these blueprints can actually, with the help of AI, can consume them without having to build out anything out of that, simply because the AI knows the blueprint they want to actually follow, and can actually help them to instantiate this blueprint in reality based on that particular problem they have. Same thing as debugging, for example, AI can actually debug with the help of logs, with the help of observability tools, with a whole lot of information in a short period of time, and actually even running so many tests and so many permutations and combinations, and finding different different errors, bugs in real time. without someone having to actually go out there. So basically, without actually asking without without discovering, it could be something that is continuous for an AI, rather for a human being. It's a job that is actually instructed or it's necessitated. Whereas for an AI, it could continue to look for opportunities, real-time debugging to actually see where there are fault lines or failure lines. OSS contributions is a place where there is a huge opportunity for AI in the sense that for different open source software out there, they have a specific language that they've written. They've got a style of contribution. They've got a coding kind of style, or they have a style guide. They have a what do you call it, an instruction-led set of contribution style or contribution framework. So as such, it's actually very important. It's actually kind of easy for an AI tool to pick up the contributions from the past, what is considered to be excellent contributions into this space, and having a problem or having a gap, the AI tools can actually come in and actually fill those, what would I say, yeah, fill those gaps and then seek for approvals, look at the approval responses in terms of pull requests, see what people are actually talking about and how it then it can react to that. Since basically it has now become conversational, so it means when someone actually responds to a pull request by commenting or by disapproving the pull request, the AI can quickly understand what is actually what has actually gone wrong and can actually remediate that in real time. Um, and AI could be leveraged in the same way in your API lifecycle, in augmented development of software using Copilot and all that. And also, it's just that in areas where we have expertise that are, so for example, when we talk about ultra low latency Java programming or ultra low latency C++ programming, all that, AI has come at a great time because it can actually help providing that same level of expertise when it comes to applying certain best practices at those kind of level when it comes to that particular programming space. And it doesn't have to be an expert in any of these concerns anymore that does this, which means we can architect for low latency, we can architect for high performance without having to be an high performance professional per se, because the AI tools can give you those expertise out of the box simply because they know what to leverage and the information is out there and they can actually bring it all together and do it over and over without making mistakes, without any error of judgment. API abuse is one thing. While it is easy to detect fraud, it is easy to detect security vulnerabilities. Abuse is not easy to detect. But with different AI technologies today, it simply means that you could actually understand real time deviations in the behavior of the way people interact with APIs, and as such, you could actually detect API abuse leveraging AI tools. And then in terms of operations, basically maintaining an SRE for APIs. Anyway, AI has a very strong capability in actually helping in that area as well. So other opportunities beyond today, we do have um, different opportunities that AI present, basically in actually coming up with advanced communication protocols that are focused on AI to AI communications, or more focused on prompt-based communications and at different levels of the OSI layer. So we could be talking about level 4 or level 7 or level 6, and we could leverage AI in actually evolving the different communication protocols that exist today beyond HTTP, TCP, or gRPC and the rest. And also what we're looking at is hyper intelligent autonomous systems, systems that actually do not need to be programmed, that can program themselves on the fly based on what they're seeing and based on uh, what I think is best. In fact, this is human intelligence in real-time programming and in real-time deploying. And it's the same thing as autonomous assistance. Expertise in different spheres of life can actually be codified, and beyond that, it can be amplified in real time without being tinkered or pushed into the right direction. And no-code solution is also an area of opportunity, simply because if AI can actually do a whole lot of the programming and development, then it means that no-code solutions will be on the rise for redundant programming tasks, such as integrations, for example. And limitations of AI. So one area that has been um, has been talked about in different fora is actually the lack of intuition from AI. Even intuition actually plays a critical role when it comes to problem solving, and also when it comes to architecture. Also, there are ethical considerations when it comes to API architecture, probably that an AI wouldn't touch upon. The heavy dependence of data or over reliance on data on AI's what I call it decision making processes is actually a limitation, simply because poor quality data leads basically to flawed outcomes, and as such, um, your AIs or the AI tools you use are as good as the data that you provided. And also, when it comes to out of the box solutions, um, or areas where you need ingenuity, you're not likely to find an AI that provides you this ingenuity out of nothing. So the ingenuity of an AI also depends on the ingenuity of the data or the people that surrounds it, the people feeding it the data as well. So it's limited to some extent that point. And then case study of a screen API, basically where there are entities that require screening. So many things can happen in the sense that people could actually try to replay a screening or try to rescreen themselves for as long as possible. And as such, um, this might not be a technical issue in reality, and no crime might actually be committed. But we talked about API abuse previously, and it means that you need something as sophisticated as an AI tool to actually understand what a illicit attack is in real time. Basically, you need someone that can perform the job of an inspector or a police investigator in real time to be able to identify this kind of anomalies. And also, it means that AIs could actually perform autonomous interactions in, let me say, proactively asking for example, supplementary information, or probably requests for information in real time while an API interaction is actually happening. And apart from that, also, it means that with the ability with an AI tool in place, you could actually perform intelligent routing when it comes to screening processes, for example. And that's it. And we pose the question that what do we think is possible and impossible? Well, so many things are possible when it comes to predictions and trends in AI. Um, to some extent, in the future, we think AI can actually achieve human level intelligence and creativity, that AI can power autonomous cars, and then they can dominate the roads in the coming years. We believe that the rise of AIs can actually, let me say, spring up digital clones of experts, because when people become experts in a field, it means that those the expertise can be codified. There is a huge body of knowledge, and also it means that with a whole lot of experts contributing to AI or actually providing data to what I call it, a data platform, there are AIs that can be trained to then become experts in this field. And with generative AI, this has just become much more apparent that it's going to happen sooner than later. And AI would also reshape global superpower dynamics, in the sense that the countries with the most intelligent and well-deployed AI tools will become much more a superpower in the future. And that will be the shift of it's a technology that is actually going to rebalance the calibration of power. And also AI is also going to push for near perfect robotic automation. And the question is, can AI replace the API architect or any architect at all? It will actually amplify the craft of so many architects out there because it can actually make you do your work better. It can make you do your work faster. It can make you cover a larger scope. It can make you work on more projects without having to do some work manually. And also means that you don't need as much architects as that. And probably some architects would actually do other jobs and actually leverage AI for architecture as well. And also, would it replace some architects? As I said, yeah, but also it then means that some architects would actually just do something else, then leverage AI for API architecture. And it depends on the scale of the project, depends on the scope of the project, the enormity of the task at hand, and for different things, some people would need an architect and some people wouldn't need it because they don't have AI that they can leverage. And some architect would actually contribute to creating AI tools or AI apps that can actually replace them. But essentially, they are working on actually making that particular practice better. And this calls for question, but uh, this is the end of the